Hi everybody, it's Crazy. It's Friday, and it's time for my UpBGE video. Now, before I get started, I got a little bit of an announcement. My Oops videos are going to go to once a month. The only reason why is because I really don't have a lot of content that is new. It's kind of like the same stuff, and I'm just working with a little bit more and a little bit more. So I'm kind of going to hold off on that, and when I come up with something next step, I will put that as a video. So good news for my UpBGE video, it goes to 3 times a month. Okay, so that also depends. It may go to 4 depending on if I have an Oops video to put out. So before I get started, got to give a shout out to my trusted because you guys rock. To my crazy fam, I love you guys. And to my patrons, thank you for your support. Okay, we are up to episode number 5, and I left off with animations last week, and so let's go ahead and get started. Alright, in this context, animation refers to the technique of making things change over time. For example, animations can involve moving an object, deforming it, or changing its color. To set up an animation, you create keyframes, okay, which are basic snapshots in time that store specific values pertaining to the animation. Okay, the software can then automatically interpolate in between those values to create a smooth transition. Keyframe 1, keyframe 2 goes smoothly between. Okay. The image below shows Blender's dope sheet editor. The dope sheet allows you to see the various properties that change during an animation. The horizontal axis represents, okay, let me get my mouse in the way here. Okay, the horizontal, okay, axis represents time. The vertical axis, okay, axis shows the various properties such as location, rotation that are keyframed. Okay, so it shows you, location, rotation, either on X, Y, and Z, and basically this is the length of it. This goes for this bar, this goes for this bar, as it goes to this one, and so forth. Okay? The easiest way to animate is to alter the location, the rotation, and scaling of an object over time. For example, by altering these variables, you can realistically animate the movement of a bouncing ball. This little guy right here. Okay, you can animate this and make it work. Okay, keep in mind that the curves represent the value of the channels. In this case, X, Y, and Z location, which is these guys right here. Okay, of the ball, not the actual motion path of the ball itself. Okay, it's not this path, it's actually this right here. Okay, so as you're looking at the dope sheet, this is what you will see. Okay, to animate something more complicated such as a human or a creature, okay, it's not enough to just move, rotate, and scale the object as a whole, because a ball is considered a whole object and it would bounce. Okay, this is where armatures come in. Armatures are skeletons that can be inserted into a model to control the model's deformation. These guys right here are called bones, and they're connected together to create a skeleton armature. Okay? Using this system, you can create complex yet organic looking animations. In other words, you can make this little guy's ears move, you can make his nose wiggle, you can make his cheeks pop, or make him talk. So you can make them do more than just the bouncing ball effect. You got a ball that just bounces, and that's it. Or you got a character that has wiggly ears. Okay. A third way to animate is using shape keys. Shape keys are snapshots of the mesh in different shapes. Okay. They are often used to animate nuanced changes that cannot be otherwise easily animated with armatures, kind of like facial expressions. Facial expressions, if they're keyframed, or not keyframed, they use shape keys, then those shapes could actually make the mouth move better so than trying to make each armature move. Okay. Finally, keep in mind that making objects move doesn't always have to be a manual process. You can also make objects move by using the physics engine. Well, they'll cover that in chapter 6. We're on chapter 1 right now, so we've got a little bit to go. Okay, so on to next is game. Okay, so far we have talked about 3D at length, but how does the game engine fit into? Well, a game engine simply takes the existing 3D assets and attaches a brain to them so the objects know how to respond to events like a keyboard press, mouse click, collision, so on and so forth. Okay, the brain can be in the form of logic bricks. Okay, we'll show logic bricks here in just a moment. I actually had somebody ask me about that in the comments on a previous video, and this is what they're talking about. They're talking about logic bricks, which can perform different actions depending on the user input. Scripts, which can extend the functionality of the logic bricks, okay, so it can make it do more so, okay, or other physical properties of an object, such as rigid body settings to make an object tumble and fall realistically. Okay, so we can do that. Okay, so 3D object plus game logic equals game. Okay, so very simple process. You make an object, you put some logic to it, and hey, it becomes a game later on when you put all these together. Okay. A game engine is made up of many distinct components. Okay, just to name a few is the rendering engine. Okay, turns the 3D scene you've built, including models, lights, and camera, into an image to be displayed on screen. Right there. See, it renders that picture to the screen so the player can see it. Okay. Basically, in Python, that is also what they call blitting. It puts it up on the screen so the player can see what's actually being displayed. Okay. Physics handles collisions and physical simulations of objects. So if a fish swimming through the water runs into another fish, he has a choice. He can do something. He can either run into the fish and both of them fall dead, or he can eat the other fish. Or there's some kind of logic that the physics does that says, okay, when you come in contact, this is what you're gonna do. Okay, you got logic and scripting, the brain behind a game. It reacts to the user input, makes decisions, and keeps track of what's going on in the game. Okay, so in the game, if you press the K button, the K makes him swim forward. The H might make him swim backwards. Who knows? Okay, and then you've got your sound. And sound produces audio events. So when you hit K, it makes a swishing sound of him swimming forward. Or if you hit the H, it makes him swim backwards. Or in most cases, if you hit the A and the S, it will make a forward and backwards sound. Okay? The above list is not meant to be exhaustive. In other words, that's not the whole thing to game making. There's a lot of other things, but these are kind of like this to get you to understand. Okay? But it should give you an idea of what a game engine does. Okay, these give you a basic idea of what it does. It renders the all the scene to the screen so the player can play. It adds physics so it can do stuff. It has logic, so that way whenever you press a certain key or you do something in the game, it knows what to do. And then of course you got to have sound, because a game without sound is kind of boring. Okay, so the Blender game engine gives you a lot of control over each of these components, which you will learn one by one in later chapters. Okay, so you're going to learn all this. Okay, so let's go to last but not least, since where I'm going to end today. It's called quality versus performance. Now this is important. Okay, this is very important in game design because you've got to sacrifice a little bit to gain something a little bit better. Okay, so you got to sacrifice a little bit of quality to get better performance, or you sacrifice performance to get better quality. It's a balancing act. Okay, so making a video game is a constant balancing act between quality and performance. As artists, you want to make the virtual world as rich and detailed as possible. On the other hand, you need to make sure the game can run smoothly for people who might not have top-of-the-line computers. If you don't have a 3080, guess what? You can't play this game. Yeah, you don't want to have to only make your game for that type of player, because not everybody has a 3080. All right, so later on in time, if you're reading this in the future, this probably 38 is probably slow as hell, right? Excuse my language. All right, so throughout the process of the game making, you will run into cases where you have to make a decision whether to prioritize the visual quality or the performance of the game. You will also learn tricks to achieve high quality visual without compromising the performance, as well as how to optimize the game by identify what is slowing it down. So if you've got a really heavy intensive scene, it's going to start slowing your performance. You'll watch the rasterizer fall, you'll watch your frames per second fall, FPS, it'll fall like crazy. So that would be a signifier that, hey, you got to do something a little bit different with your game scene because it's taking up too much. Okay, it's eating too much memory and it's just slowing your system down. Okay, and if you got a slower computer and somebody tries to play it on even a slower computer, it's going to be like 2 frames per second, which is very boring. Okay, so that's where I'm going to end off for this week. We're gonna go into setting up. Okay, basically setting up a game, okay, next week. So keep in mind that this is a very big book, so it's going to take a little while to get through, and once we get done with it, hopefully it gives you a little bit better idea of what's going on and how to actually build games. And if you've already started a game and you're just following along with this to try to get a little bit better knowledge, kudos, and I would really love to see your games. If you would like to show off some of your prowess, drop them on into the comments below, or look in the description and you will find my Discord server, and you can drop on in and say hi and show me some screenshots of your game or how far you've gotten, and I would be more than happy to post them on my videos. You may be one of them lucky people who have inspired me to make more. Okay, so check me out next week. Till then, next time.